Going to get started talking about keeping secrets in your infrastructure as code. Oh, my clicker has died. So to start with, might as well start off with who am I? So my name is Peter Souter. This is actually a little bit out of date. I'm a technical account manager at Puppet. I help out with customers from the Puppet enterprise side. I used to teach Puppet classes, but I still evangelize and work with the Puppet community. I've been working at Puppet for about 2.5 years. I've been doing the DevOps probably for about 8 and using Puppet for about 8, I guess. And I love doing these kind of events and speaking about the stuff that I've learned over the years. So why are we here? In this room specifically, don't want to get too philosophical. So Puppet is pretty good for security. So the core idea behind Puppet, good question to start off with. Who here uses Puppet right now? Oh, good. And who here who doesn't use it knows of it? Okay, that's basically 100% of the room. So good start. I don't have to explain too much of it. So Puppet's pretty good for security. The whole idea of infrastructure as code. So the idea is if you're modeling your servers like code, you can have nice, uniform, secure machines. You can lock down your access to that infrastructure. You have a nice audit log of what's happening. You can track those servers. You can enforce maybe compliance standards or some sort of security standards. And you can tie into tools that do intrusion alerting and things like that. And I mean, it's a lot easier than having all those kind of on-the-fly security rules that you might have. People randomly connecting into boxes and changing things. But there's a big thing. In law enforcement, they call it the Cockroach Problem or the Loom Problem, where if you try and push all the problems from one place to another, obviously they just reappear somewhere else. So if you use Puppet to solve all the security problems, then you're putting all of your eggs into one basket, and you want to make sure that Puppet doesn't become where all of your problems lie. So it's easy to take all that technology to solve a problem and move all that problem onto another stack. So we're going to talk about how to avoid that. And you've probably seen this picture before in a tweet. The original version of this was dev on the left and ops on the right. And the new version of this now, people talk about rugged DevOps or DevSecOps or DevOpsSec. And the idea is that lots of places have really attuned to this idea of devs and the development teams and the operations teams working together, but then a lot of the times they still kind of end up throwing that over the fence to operations and say, we've done all this really cool unicorn stuff, now you need to make sure it's secure, which is a bit after the fact. You don't want to do that. So show of hands in the room, who would call themselves a security person as their main job title? No one, okay. Who has a dedicated security person in their planning? Maybe you do Scrum or maybe you do Agile or something like that. Cool, a few people. And who has a dedicated security team in general? A lot more hands, okay. So maybe some of the things we're talking about are going to be in the far-flung future. Maybe some of these things you can start doing from now, but it's all the sort of general idea of how to make sure that you can secure your Puppet code. Or your infrastructure as code, obviously for the few hands in here that didn't say they use Puppet, I can talk about how I'm from Puppet, I've used Puppet all this time, so this is what I'm going to be talking about, and I can say other stuff might apply, but since pretty much everyone put their hands up with Puppet, we're in a good spot. So we're going to cover dealing with secrets with tools like Puppet. We're going to be keeping your code clear of plain text passwords. You're going to be using dedicated detecting your leaked credentials, and we're going to be making security part of your code review process. So how do we deal with secrets in infrastructure as code in the first place? So to start with, if we have a problem, we need to define what the problem is. So what are secrets in the first place? So this is a pretty good definition from Noah Kantowicz's talk, which is called Behind Closed Doors. And basically, secrets in IT are 4 things. They are small, so a few kilobytes at most. If you think that you've got an application that's a secret, then it's not really a secret, it's an application. Maybe the config for that application is a secret, but generally it's going to be something quite small. It's radioactive, i.e. something bad will happen if people outside of your organization, or maybe even people within your organization, but in the wrong group, find out about that information. They're required, because if you have something that's radioactive and small, but not required, then just get rid of it. And that's a lot of the kind of idea behind some security stuff is making sure that you don't have to do this in the first place. So how it's easier to not use passwords and use keys, but then obviously the keys become the new secret. So the common examples, passwords, API keys, SSH keys, SSL certs, and things like that. So how do we avoid exposing these secrets in Puppet? So the easiest to the hardest, the easiest way and more the kind of obscurity rather than the security kind of way here is just remove them from the logs completely. Then you actually remove that data from the Puppet code in general, encrypt it, and then lastly use a dedicated security service. So maybe something like Vault. So the most common thing to do, don't expose your secrets in the logs. This is especially good if you're kind of in a multi-tenancy style situation where maybe your ops team or maybe a certain team or maybe a team in a different area don't have the permission to see a certain password, or maybe you want to ship those logs somewhere where maybe people are outside of a certain scope can see them. So let's just remove them from logs completely. So in Puppet, the easiest thing to do is just turn show diff to false. So it's pretty anticlimactic. We have a file called etc sensitive. Inside there we have some content we don't want to show up in the logs. But every time we run it with Puppet, you can see it's showing the whole diff between the two files. That's bad. So what we do is we then turn the show diff to false. Then after that, there we go. And we're saying that the secret password in there, hunter2, we want to make sure that show diff is false. And then this is actually in our MySQL supported module. So we actually have a bunch of modules on common applications that are out there. So for example, Postgres and MySQL on the Puppet Forge. So this is an example of some live code that we actually support. Inside there, we're saying for the my.cnf file, which has might have the password for your MySQL server, we want to show that as show diff false. Then when we run it again, you can see it shows it will show, there will be a message saying that has changed, we won't actually show the content of those changings. So there's a balance here, and just like anything in security, there's always a balance. If you're hiding these diffs, you're going to be reducing the visibility of the change that's happening. It's part of the sort of process that comes with security stuff. Sometimes you make the sacrifice of making things a little harder for people, but if your required use case is you need to make sure that those logs aren't being exposed, then that's kind of the balance that comes there. So one of the things you can do if you're using a sort of config file that has an ini file-like content is you can actually choose which bits you care about being exposed. So ini file is basically a module from the Forge. So instead of managing the entire file as a static config, you manage individual chunks of that config file. So for example, instead of managing an entire .txt file, you look for a regex for a particular line, you make sure it's there, and what you can do is say, this one I care about, this one I don't. So ini file module has the ability to choose when you show diff on something like that. So I've got a config here for my Acme app, and then I've got a time zone, and I've got a password. The time zone probably isn't a secret. Maybe it is if you work in a company that really cares about the time. But in this case, I'm saying that if someone sees the password, that's a big deal. If someone sees the time zone that we're in, it's probably not a big deal. So that's another way of doing it. So from Puppet 4.6, oh, that's a good question as well. What version of Puppet are people on? Who here is on Puppet 4, the people who are using Puppet? A few hands. Who here is on Puppet 3? A few hands. Who here is on Puppet 2? No hands. Okay, that's good. So, but in Puppet 4 and Puppet 4.6, we added a new sensitive type. So all it is, it's a new function in the Puppet 4 language, and it basically gives the ability to confine a particular string to be sensitive, and then Puppet will just go, okay, well, I know that this is something that I shouldn't show up in the logs, and then the idea from there is that you then unwrap it. So in this case, we're saying for the etc sensitive file that we had before, the password is still in there as hunter2, but then when it goes through, it's showing redacted to redacted. So we can see that change, but specifically it's saying this has changed, but I don't care about this bit. So Ben Ford from our education team, he used to be a pro service engineer, so he likes hacking on stuff. He made a little tool called Node Encrypt. So what this does is it pushes the encryption from the master side to the agent side. It actually encrypts the content of that config file from the SSL cert from the machine itself. So in essence, instead of having it from a central control point on the master, you're encrypting it on the agent side. So basically, it's built on the CA that you already got because Puppet uses a certificate authority to do things in the first place, but then it's encrypting it on a cert basis. So it's pretty cool because it means that if you have servers where maybe you've got a team that can look over the entire estate, they can't log into a particular server, they can encrypt it in that basis. The problem with it is that it's more of a one-on-one basis because it needs to be encrypted on each individual agent, so it's a little bit hard to control, stuff like that. And You can see the example is pretty similar to the sensitive type we did before. So Ben's idea from this is what got turned into the sensitive type, and then some of the encryption stuff we'll cover in a second as well. So that's the first step. We're basically, all we're doing here is pushing the problem less, making the secrets that are showing up less visible in the logs that are happening. So the data is still visible in the code, but at least when the logs are coming up, you can't see those secrets. So then from there, just like in any sort of core application you want to do, we're going to be removing that sensitive data from the code itself. So if someone, someone's laptop gets stolen or someone accidentally pushes to the wrong repo and someone gets a clone of your Git code, they won't be able to see those secrets as well. So Puppet uses what's known as Hira for the data layer. So what this does is instead of having your config hard-coded within your Puppet manifests, it goes and pulls that from, by default, YAML or JSON, but it could be from a database, it could be from an application, an API. But for example, this is some YAML config I use to set up a GitLab server. So inside there, it's setting up things like the LDAP, it's setting up what ports it's going to run on, things like that. The problem with that is that obviously because it's this YAML file, anyone can look into it and they can see their password and get back to where you were before. So if someone gets a copy of your code, they can see your passwords, it's very bad. So you don't want to do this. Instead, you want something like this. So this is what eYAML is. So eYAML, encrypted YAML, so it's a good name. All it does is it basically goes through your YAML files and it will encrypt the values with a private key that's kept on the master. So the idea here is that back in the day when people were starting to ask the questions about how to encrypt stuff with Puppet, there were tools out there like Blackbox, like Gitcrypt. The problem with that is that it's pretty difficult to use, that you had to unwrap the secrets every single time, and it just wasn't super useful for the average consumer. So Hira YAML is basically the standard we use to encrypt stuff these days. If you're not using it right now, I really recommend it. People have already written plugins to go into it. I worked for a customer that plugged their eYAML into a hardware encryption module, so then the idea would be that the main server was actually plugged into this hardware PAM thing, and then the idea would be that even if someone got the repo, and then even if they got the keys, unless they had the two-factor from the actual physical machine, they couldn't actually get to the password. So they're pretty secure there, as long as no one got into their actual data center. And it's probably, the best method of encryption with Puppet. And it's widely used. There's a bunch of plugins, as I said. So there's a GPG plugin. There's a secret box plugin. There's KMS, so you can actually tie it into Amazon's key management service. And you can even tie it into two-factor. It's not that hard to extend. So if you're using something like Google Authenticator, you can make it so your server actually reached out and talked to a second factor authentication for that. And the idea here is that Puppet will be able to natively do this in the future instead of having to use a plugin. Obviously, the problem with encryption and stuff is it's very difficult. It's very easy to say, oh, we just thrown in some password authentication stuff in there, but having something that actually lives up and then we can support properly is a lot harder. So if you're interested in that, there's a ticket out there to go follow. But otherwise, this is the stuff we're talking about now will be the main way of doing it. So a side note, I mentioned just now the VCS-based encryption. I'm not going to talk too much about it. It's pretty deep. It's a whole different ball of wax. There's a really good talk up there. Where is it? Yeah, there. It's Daniel Summerfield, Turtles All the Way Down. He actually mentions things like eYAML, and basically he goes through things like Gitcrypt and Blackbox. The problem with them is that they're not super easy to do. The files have to be you're actually encrypting the file itself, not the content of the file. So it's a lot harder to manage because, just like with Puppet, you'll be changing one static file to another rather than seeing those individual parts. But this is how people used to do it before things like eYAML existed. So Wikimedia, which actually used Puppet for all of the various parts of the wiki world, so things like Wikipedia itself, they use Gitcrypt. Blackbox is what Stack Overflow were using for their Puppet servers out there before eYAML existed. So going deeper with this, so dedicated secret devices themselves. So why would you want to use a secret server in the first place? So who here is using a secret server of some sort? So maybe Vault or anything else like that? Yeah, a few hands up. So it's pretty cool because secrets and security stuff in general, the UX is generally the first thing you have a problem with. If anyone's tried to actually create a GPG key on the command line without remembering all the flags, it's not super fun. So having an actual supported way of doing this from a server and actually having things like access control lists, so this group can look at your passwords, this one can't, or this one can, but only for this 30 minutes of time and that kind of stuff, It's a lot easier than having to do this all manually. You can do things like leasing, as we said. You can have auditing, so if someone's like, who was the person who made this change? Instead of having to go find the person physically, you can say, well, this person logged in at this time, and obviously that logs into things like Active Directory and LDAP and things like that. So the big ones out there that you've probably seen, Vault, Conjure, Keywizz, Amazon's KMS, and Confidant. And the thing about Hira is that it's basically just glue, Ruby glue, to talk to a different service. So as long as you have something that return a value when you give it a key, you can use Hira to go talk to it. So I've been playing around with Hira Vault, and I've actually helped a few customers set this up. And the idea here is that instead of having to go encrypt the stuff yourself, you push all of the secrets part of your estate onto the Vault server itself. And then you actually have a supported product that you can HashiCorp, do good stuff. And then from there, your Puppet code will always go, I'm going to go look in Vault for this information. And Vault has some cool stuff around actually generating certificates on the fly. So you can do that kind of stuff as well. So you've done all that stuff, maybe using a secret service, but how do you actually make sure that your existing code isn't full of secrets and you aren't just exposing them all already? So this is where you're actually making sure that you're not only are you not exposing your secrets, but there's not a history of your secrets in your public code already. So there's a good point that I always like to say when I'm at a customer is that theoretically you should be able to release any code that you write with any sort of problems. So yeah, you're not being forced to do this. It's not like a rule of Puppet. But it's a good thing, not just in Puppet world, but in any kind of language, that the bits that are abstracted out, so secrets and things like that, should be pulled in such a way that if someone accidentally force pushed your code to GitHub, there wouldn't be any problems. So this is actually a tenant of what's known as a 12-factor app, which is a framework for modern applications. And it specifically mentions, as you can see here, basically, if you want to make sure a litmus test to whether your app should be correctly configured is that if your code base can be made open source at any moment without compromising any credentials. So GDS, the government digital service, I was there working on some of their stuff before, and they're a big Puppet user. So if you go to gov.co.uk/register to vote, I helped build that. It's all Puppet under the hood to do all the kind of register to vote stuff right now. We've got an election coming soon, so hopefully that's all powered by Puppet. But they have, in GDS, there's one that's known as the Digital Services Standard, which is basically a framework for any work that's being performed that has been made open source at some point. And the idea is that the code that's being written by people within the government, it's technically public property, right? We're paying our taxes to do this stuff. This is the kind of thing that can be reused, not only by other companies, but by different departments, and open source is cool, right? So for a while, GovUK wasn't open source because they had passwords in there, they had keys in there, and it was one of those things that was always in the icebox and always on the backlog. And eventually got around to saying, we need to go fix this. So, and they even mentioned the 12-factor we just talked about. So what they did, there's a blog post where they talked about some of the things they did. This is a ZSH, uses a ZSH function for the strings. What this is doing is basically, the catalogs all of your current manifests, takes everything that's a unique string and puts it in a big list. And the idea is you can look through stuff and you see something that looks alphanumeric, you can be like, that's probably a password, let's check that out. So one thing that's important is it's not just the code that's a problem. Remember, everything that you put into your version control, there could be logs in there that have secrets in there as well. So hopefully no one's ever done anything like this, but it's possible. You might even accidentally mention something, even references to things like URLs that might be secret or IP addresses and things like that. You need to make sure that anything that's out there is cleaned. And here's a one-liner that they mentioned in the blog post as well. And basically this goes through the Git log and looks for anything that could be a secret. So you want to know more about that? It's a really good blog post. Maybe if you're just interested in how the GDS actually use Puppet within their organization, or if you're just interested in maybe doing something like this and going through your code and getting rid of your secrets, it's a really good blog post for that, because it's a good practical example of someone actually doing it. So now you've done that, you've gone through, how do you make sure that you're not accidentally putting secrets in after the fact? So one really cool tool is Truffle Hog. So what this does is it basically goes through your entire Git history, both commits and your code, and it will look for anything that looks like a complex string. So there's going to be a lot of false positives when you first run this, especially if you've got documentation. But the idea here is it will look through your code and go, here's something that looks like a complex string, it might be an API key, and then it will highlight that, and you can go through and fix them all. So in this example, I've got some code here, looks like Java code, and inside there, I've got the AWS access ID and AWS secret key. So if I accidentally put them in there, that's bad. I can go in there, clean that up, and fix it all through there. There's also GitLeaks, which works in a similar way. So what GitLeaks does is it's slightly more specific to certain things in logs. So we'll look for anything with the word AWS, API, secret, key, password, SSH, and things like that. So it works in a similar way. But it's a little bit more intelligent. It can tell you what is actually going wrong there rather than just showing you these random strings. And lastly, there's always manual grepping, some awk, some sed, or something like that. So this is something that I just came up with. Basically, go through git grep, look for anything that has the word username, API key, or anything like that. And that's the thing about a lot of this stuff we'll be talking about in a sec. There's no silver bullet for this. There's even companies out there that try and make these kind of tools, and we'll talk about that in a sec. But there's infinite amounts of things that could be secret. What's kind of good that's happening these days is that companies like AWS and even companies like Instagram and Twitter, who aren't primarily developer companies, they've actually started proactively looking for things that could be API codes and retracting them for you. AWS did that a lot after all the people had their AWS accounts. People, accidentally pushed their AWS keys to GitHub, and then people were mining Bitcoin in them. So AWS actually proactively go out there and look for keys and revoke them for you, which is cool. There's a crutch, don't rely on them to do that. So now we've gone through our code, we've got through all these leak credentials. How do we make sure that we proactively find any leaks that have happened already? So Netflix made a tool called Scumbler. So what it is basically just a Rails app, but it will proactively go out and talk to APIs from various services, and it will try and find anything that looks like a secret. So this is the example they gave when they gave a talk about Scumbler at a security conference. And what they do is they have a GitHub search that looks through their private GitHub, that looks through and looks for things like AWS_RSA or begin RSA private key, which means that someone accidentally committed a private key into their repo. It also looks for, this one's actually slightly more advanced because it will look for known bad Java application things, because most of their applications are Java applications. So it will look for methods that they know are insecure and say, flag this up and go through there and make sure that's not there. So there was briefly a website called GitLeaks that basically did some of the stuff we're talking about as a service. But it disappeared. I actually gave an early film this talk a few months ago, and it did exist. And then I think there was a sort of internet backlash against it because they were basically like, oh, here are your leaked credentials, and if you pay us some money, we'll tell you more about them. And people were like, that seems a bit mean. So since then, they've disappeared. But it's a similar sort of idea, is that it proactively goes out there and looks for these AWS keys. But as we said, there's no silver bullet for detecting leaked credentials. There's so many different ways they could be. You might have a different way of doing stuff internally in your company, but these are some of the easy ways of catching some of this stuff. And a lot of it, and this is the constant refrain that we have in IT in general, is that it's not a technology problem, it's a people and process problem. And making sure that you have the right review process and gates to find this kind of stuff. So a lot of this is making sure that security is part of your code review process. So earlier on, when we said who has a dedicated security team and who has security people in their sprints and meetings, there wasn't many hands up. I think it's a really good pattern because it means that it's kind of like when you have your UX people as part of a sort of project planning meeting. They can be there and say, I think we should come into the plan and say, if we're doing this, I have some concerns security-wise. It's easier to get them earlier on in the process than it is later on in the process. And at a minimum, you want to make sure that the code that you're doing doesn't make things worse. It's a pretty standard thing you want to do in software. If you're making things worse, things are probably going wrong. And as we said, it's largely a people and process problem. So you want to make sure that your security changes are part of your process. You want to shift security left, because the further down you are on the software development path, the harder it is to make a change, with the hardest one being that you've created something that has a hard-coded password and everyone's very upset with you. So there's a really good short book about this, basically a book called DevOpsSec by Jim Bird. And he basically talks about some of the processes here, and he has some really good use cases of companies that started bringing the security team into their process earlier on. So how do we actually do that? What are some practical examples of making sure we don't make things worse? So game days and internal evil attempt teams, or red teams they're often called, So, theoretically, what would happen if someone got access to one of your boxes? How much damage could they do? Is everything isolated to a certain extent? If you're using a secret server, like what servers have access to what? If you're not using secret servers, if someone gets access to one sort of insignificant box, how much could they escalate from there? Could they get more bigger production passwords? There's a lot of things like having CI tests for some of the security things, so making sure that all of your dependencies are up to date. There's tools like SICK, and there's tools like very application-specific tools, but for things like Puppet, making sure that you can actually scan through and make sure your packages are up to date. Having dedicated security stories, so either having people in your sprints or having a story called like security stuff and actually figuring some of the stuff out. Having embedded security people in your teams, and having dedicated audits from outside firms. If you're big enough and you have enough money, there's really cool stuff. We've had lots of either customer focused or actual, from our perspective, looking at our software and making sure that we're up to date on all the security things. So this is a pretty good game day example we use at customers a lot, is basically agent spoofing, is saying, like, let's say you have a dev instance, someone gets access to it because dev instances are generally slightly more fuzzy with security stuff. If someone gets access to that, how bad could it be? Could they escalate from there? Could they use the credentials on there to get a production password? So we were working with a customer where they were using the same password everywhere for their database. So before they were using Puppet, they were doing this stuff through shell scripting, and they're using the same script everywhere. So someone on their red team got access to one of these agent boxes. So they got the password to put the production password, and it was something like prod-example-db.com. So they're like, dev-example-db.com. And they're like, wait a minute, prod-db, use the same username and password, boom. They had production password credentials. So it's the kind of thing that's better to catch early on in the process than it is before it's actually out there. And a big thing is to make sure that you don't become a blocker with this security stuff, because the thing about security is that if you make it a blocker and if you try and slow people down by saying we need to make sure that things are right, people will just go around you. It's all about shadow IT. And security definitely has this, there's this kind of attitude around like the security team in general. Who finds that a lot of the time the security team is just fighting them and they're making your job slower? Yeah, most of the hands go up. You want to make sure you don't get into the adversarial position. Like sometimes it's part of the process, and sometimes, if someone's doing something really bad, you need to make sure they stop doing it. But you want to make sure that there's a bit of give and take there, and everyone sort of gets their views across. You can actually talk about this kind of stuff. So what do you actually do when credentials leak? Basically, you want to clean up your code base. You want to find out how bad things are. So easiest things to do, these are very easy to say, harder to do in action. Roll new keys. So basically don't just go, oh, well, that was only up for a few minutes. There are bots and miners out there that if your API credentials up there for like a fraction of a second, they'll be owned and then used on the internet within seconds. So roll everything, reset passwords. If you're in a world where you're kind of livestock, not pets, just destroy your machines, bring them back up. There was actually a pretty good post-mortem on a hack that happened at a Bitcoin, I think it was Ether coin. And basically one of the problems was that one of the people there was an insider threat, and he left a bunch of open ports on his developer machine, and they kept cleaning away all the servers and then bringing them back up and cleaning away all the servers, but they always left his dev machine behind. So every time they did all this stuff, they had entire audit teams come in, but then every time they got everything back to normal, he would just turn back his tunnel on and just start stealing all their stuff again. So the easy thing to do is just clean everything away and start again. If you're using a tool like Puppet, you can actually do that most of the time. And the big thing is monitor systems for strange behavior, because the average time for a leak from the leak actually happening or credentials being leaked to anything actually happening is normally about 3 or 4 months. So if something happens and you've detected it, things might already be bad. So if you've got good metrics, if you've got good logging, you should be able to detect the stuff that's going on. If it's things like making sure the machines, like why are there random CPU spikes when nothing's happening? That might be a worm or something bad happening in the background, or people stealing all your stuff. Like being able to monitor things like traffic and going, why is the server that shouldn't have any traffic on it in the first place using up all this bandwidth? It might be because someone's SCPing all of your secret stuff. And yeah, we talked about before, a lot of services actually proactively will detect things like leaks and clean them up for you, but you can't rely on them for that. So what have we learned? You want to make sure that you remove sensitive data from your logs in the first place. You want to encrypt that data separately with things like high-rate YAML. You actually want to ensure that your code stays clean after you've done all this encryption. You want to make sure that your security is moved left and it's actually part of your process. So if you want to know more, there's a really good talk by Noah Kantrowitz. Basically, he goes really deep dive into how various encryption methods work, and he goes into the difference between synchronous and asynchronous encryption and things like that. Basically, this is the standard for secret talks, and I talked to him a lot when I was writing this. It's really good stuff, basically. And he actually does a lot of chef work, but I don't hold that against him. So. Cool. That's it. Any questions from anyone?